Maximum parsimony is also known as minimum evolution methods, and assumption is that evolution takes the shortest routes, and it tries to find a tree that explain the data with as few evolutionary changes as possible. And there are two basic fundamentals. Number one is that mutations are exceedingly rare events in nature, and number two is a model that invokes more unlikely events, like for example that shows more mutations, is less likely correct. So a correct model should have minimum mutations or minimum changes in it. So the relationships that requires the fewest number of mutations to explain the data is more likely a correct relationship. What we do over here is, in order to do this parsimony, we try to find about what is the information content present in those alignments. So for example, we can come up with multiple sequence alignment, and then we look into the sites as being informative versus less informative sites. So we try to rely the sites which are more informative. The sites which are having at least two different nucleotides at each position, with at least having a twice representation of each of them, can be taken as an informative positions. For example, if we look into this data set, we come with 6 columns. So column number 1 is non-informative, since we don't find any substitutions. All nucleotides are of the same kind. Column 2, we find just one substitution, so we can say it is also less informative. 3 is less informative because we don't have twice representations of these nucleotides, and same is the case with the 4. So if we take 5 and 6, we have 2 G's and 2 A's, and here we have 2 G's and 2 T's. So we can say that these are the informative sites. So we make the tree by using these sites. Okay guys, so let's take this position number 5 or column 5, and we make up these trees. So since we have 4 sequences or 4 leaves in these trees, we can have 3 different possible unrooted trees after we remove the duplicates. So in top left position, we see that we have the tree where we have, here goes our G, then we have on sequence 1 we have G on sequence 2, and in third we have A, and fourth we have A again. So we can have this arrangement, and we see there are black lines. So black lines are where we have matches, and we have red lines where we have substitutions. So in this tree we recognize that there are 2 substitutions. One is here where an A changes to G, and here is the second one. Same way we can do 1, 2, 3 and 4 like this. Again we have 2 mutations or 2 changes. In the middle we draw those internal nodes where we can have their hypothetical ancestors, like here. The third tree, we find only 1 mutation. So this is the tree which is the maximum parsimonious tree that have minimum changes in it. So this tree is the more likely tree as far as this scenario is concerned, this bottom one. Same way we can take this position number 6, and again we see that we have 2 changes right here, 1 and 1. There are 2 in this trees, and there is just 1 change in this third one. So this one is the most likely tree as far as this scenario is concerned. So we see that these maximum parsimony methods, they believe in minimum evolution. So all those trees where we have minimum changes or minimum mutations, they can be regarded as the correct trees reconstructed.